In sports, the rules are pretty clear, right? Stay inside the lines, go that way, obey the referees. In design, though, things are often a bit more nebulous. Requirements are a way of understanding the rules and boundaries of the game. Requirements define the project's scope, but also serve as an understanding of what it'll take to complete the project. How you define success and how you know when the project is complete are directly tied to how well your requirements are defined. Now, requirements often continue to develop as your project proceeds. This varies more or less depending on the type of project, maturity of your client, and the industry you're working in. But no matter what, how you handle the change in requirements is a key to success. You must clearly communicate your list of requirements often and to the relevant parties if you want to complete your design project successfully. A requirement, per the International Council on Systems Engineering, is a statement that identifies a system, product, or process's characteristic or constraint, which is unambiguous, clear, unique, consistent, standalone, and verifiable, and is deemed necessary for stakeholder acceptability. Now, a quick note on terminology. Requirements are often called specifications, but these words do mean different things, but often that terminology varies by industry. For this lecture, I'm using the terminology that a requirement is a specific statement and that the requirements are the collection of individual statements. So I'm avoiding the specification world altogether and sticking with requirement. Given that background in requirements, take a moment to write down one of the requirements from your project using the quiz link. Good. Now let's be clear that needs, which we've discussed previously, and requirements are not the same thing. Needs are often too vague to design to. They may be true, like this example, the vehicle should be fast and fun to drive, but everyone could have their own definition of what fast and fun mean for a vehicle, right? What we're talking about today isn't making a list of needs. We've discussed this previously. It also isn't explicitly how to translate between needs and requirements. That was discussed in the QFD module. We're talking about how to make a good product requirements document that you can engineer your solution to. So, given that, where does your requirement, which you just wrote down, fall on the spectrum from need to requirement? Okay, let's see how to take your requirement statement and make it really great. A good requirement is clear, quantifiable, and measurable. It's fully justifiable, that means it has a valid source. It's not overly restrictive, and ultimately, it has someone in charge of it to ensure that the spec is met within the design. Often this is your technical lead. An example of this: the unit shall verify that a car is present before beginning any charging functions. This is clear. We need a safety check before we turn on power to the system. We'll assume that it's justifiable and that our technical lead will keep us honest on this one for the sake of argument. Finally, it's not overly restrictive. I didn't say the car should turn a switch to notify the unit that the car is present before charging or something like that, where I would tie my hands on how I was actually going to construct the thing. I want to clarify expectations without locking the team into a specific design solution to the greatest extent possible. In addition to the previous 4 attributes, there are also some best practices for constructing the actual written statements. The majority of specifications should be written in complete declarative sentences with an imperative voice. Specifications should be broken down into single testable statements. The only good specification is a shall specification. Will, must, to be, is to be, should. They're desires and goals, not requirements. And finally, use simple language and avoid superlatives like best, comparisons like better than, and loopholes. Test your understanding of these concepts by completing the quiz. Now that you can write good individual requirement statements, how do you go about documenting the complete product requirements? Well, that's highly dependent on the industry you work in. For some, highly regulated environments like explosive gas atmosphere settings and medical products, the requirements document is extremely detailed. For example, a simple sensor system in explosive gas atmospheres had an 86-page long requirements document with a full verification and validation or testing plan and a complete traceability matrix to prove that every single requirement had a test associated with it. For your design project, let's stick with a simple table. Your requirements should look something like this, where we capture the date that requirements are added. This is a nod towards the justifiability of the requirement. We capture the description of the requirement using the best practices we now know, And we identify our requirements with unique numeric indicators so that they can be easily referenced in design reviews and project documentation. Notice there's an additional column we haven't yet talked about, demand versus wish. And that brings up an important point here. There is a big difference between hard requirements and wishes. As indicated on the previous slide, it's important to clearly note whether a requirement is a demand that must be met, or if it's a soft requirement that would be nice to have. One example of this comes from a team designing a person-portable backpack fire suppression system. The primary use case was for putting out fires on Navy vessels, and therefore there were hard requirements for the amount of fire suppressant dispersed and other things. However, the client also had recently watched a documentary on firefighting motorcycle units being deployed in Southeast Asia and parts of Europe. Though secondary, the client expressed a wish for there to be an easy means for this product to also be mounted to motorcycles in case it could be used in another market. The team added the motorcycle mounting requirement to the product requirements as a wish. Then, as the development process proceeded, they met with the client and let them know that despite 2 brainstorming meetings, the team had not identified a simple way to meet this wish within the current product development project. And that's the key point here. As the design process continues, soft requirements are either developed into hard requirements or are eliminated entirely. Being more explicit, how do you accommodate wishes? Communicate and iterate. Initially, set preliminary requirements. Develop metrics for each customer need and set ideal and marginally acceptable target values. Later, refine those into final requirements. You will probably want to set a key date or review during your project to confirm and lock the project requirements. One final thing that you will want to do for each of your requirement statements is make sure you can prove you met it. Another way of saying this is all requirements should be testable. Verification answers the question, did you meet the technical specifications you were given? You need to agree with your client on what you will be required for each requirement, and then you need to plan for it in your schedule. Typically, each requirement should be traceable to at least one verification event, like physical testing, computer analysis, inspection. The example at right shows that the linearity test described will be used to verify 2 requirements for this particular sensor system, the linearity error requirement and the capacitance input requirement. How will you verify your requirements? Thinking about it now is an important step. And once you've thought about it, you should capture your ideas in your requirements table, like the example shown. Great. We now know what a requirement is, how to write good statements, and how to capture our individual requirement statements into an overall requirements document. But you might be wondering, how do we know we have the right requirements? How do we know our requirements are complete? If you want to avoid looking like our friend from Futurama here, it's critical that you get a good, complete list of requirements agreed to before you begin detailed design work. It turns out this is a balancing act. If you have too few requirements, then no one knows exactly what done looks like, and so the project never ends. And if you have too many requirements, then you may have either locked yourself into a specific solution, designed through requirements, or you will have a mountain of testing and analysis to complete to prove compliance with the large number of requirements you've defined. On either of these extremes, improper requirements end up costing time and money. At a high level, complete requirements pull multiple sources together into one coherent rulebook for your design work. Depending on the project, each of these areas may be more or less populated. That regulatory and standards box can be huge in explosive gas atmospheres or medical projects. So one answer to our question of, are the requirements complete, is to make sure we aren't referencing multiple documents when evaluating our design work. Have we pulled the needs, regulations, and safety considerations into one coherent list? But that doesn't really mean we know that we've captured the whole picture. If you really want to understand a system of any sort, you need to understand the big picture. And systems engineers talk about 4 major areas: data and interfaces, also called input-output, control, or functional behavior, performance, and physical architecture, often referenced as constraints. We've introduced tools to help you look at these areas in other modules. So another answer to our question of do we have complete requirements is to consider requirements that might come from any of these tools. For example, data and interfaces via a black box model, controls and functional behavior using functional and process models. So another answer to our question of do we have complete requirements is to consider requirements that might come from any of these tools. Most engineers fixate on physical constraints only, but that's a mistake. Your specifications should capture all 4 of these areas, so let's consider how black boxes and functional models might be used. You may remember this slide from a previous presentation, but let's look at it with a new set of eyes. What crosses the boundary for our system definition drawing here? Well, we have power coming into the unit, the car, and the ground. So we need to make assumptions or requirements around the input power, the installation methods, and the restrictions of what cars can interface with this charging system. If we've missed any of these areas in our requirements, then our requirements probably aren't complete. Similar approaches can be used with black box models, system architecture diagrams, and several other top-level diagrams. Now looking at functional models. We know that functional models allow us to look at alternate architectures that can meet a single functional definition, and they allow us to think more deeply about the problems facing us. But it also allows us to start asking questions about performance indices, like what parameters should constrain the flows in this system. For this example, the electric toothbrush shown in this functional model had a very specific requirement around the rotation speed of the applicator. The client had clinical trials proving effectiveness of its product at only specific applicator speeds, so it was critical for the design process that the team knew that ahead of time. By looking at the functional model created by the team, critical functions and performance indices can be pulled, like in this example. One final way to check if you've captured all the requirements is to look at standard lists of requirements categories. The Department of Defense, Department of Energy, and many other entities offer standard breakdowns and lists of requirement areas. By looking at these lists, you may remember to ask questions or pull out requirements that you might otherwise miss. So now you're ready to develop the requirements for your project. As you begin, remember the things we've reviewed, then follow this process. First, develop a list of specifications from QFD and supplement it with lists such as Frank and applicable standards. Then, identify as demand or wish each of the requirements you've identified. Identify a means of verification for each specification. Review the list for consistency, check for conflicts, and for feasibility. Use as much detail and quantification as appropriate and as possible in your requirements, and then have the entire team review, comment on, and revise the list before presenting it to your client. You have now completed the product requirements module. Let's test your knowledge with the quiz below.